Welcome to Data Structure course. Hello students, I am Swapnil Chaudhary. Today we are going to start with our unit number 3. In our previous sessions we covered the unit number 1, that is the data structure and introduction to data structure. Then in second unit we cover the array and hash tables concept, that is unit number 2. And then we directly jump to the unit number 5, that is stacks and queues. So now we finish all these 3 units, the unit number 1, unit number 2, and now we are going to jump, unit number 1, unit number 2 and unit number 5. Now we are continue with our unit number 3, that is searching and sorting. That is searching and sorting. Unit number 3. The objective of today's session is to study need for searching techniques. Also, we are going to study different searching techniques like linear search and binary search. Okay. So, before start with what is the searching, what is the need of searching techniques, we are going to see what is the searching. So, basically searching in a data structure refers to the process of finding location of an element in a list. What is searching? Searching in a data structure refers to the process of finding location of an element in a list or particular data structure. This is one of the most important part of many data structure algorithm, as one operation can be performed on element if and only if that element we find in our data structure. There are various algorithms have been defined to find whether an element is present in the collection of items or not. But in our syllabus, we are going to see linear search and binary search only. So, if we look at the specific definition of searching, so definition of searching is the process of locating certain data from a given list is known as searching. So what is the definition of searching? The process of locating certain data from a given list is known as searching. Now, what is the need of searching techniques? What is the need of searching techniques? In our computer system, large amount of storage is available, or we have large amount of data is there. So if you want to retrieve any information or any individual records from that data or data set, we require searching. The basic example is, suppose if any organization having 100 employees, and if you want to find the information of employee ID 112, okay, so employee ID is starting from 1012 onwards. So we have 100 employees. So out of that, I want to find the employee information of having employee ID 112. So to find that information, I need to go one by one or any other searching techniques. Okay. So basically to retrieve required information or individual records from the data search or data table or data set, we need required searching technique. So how, or another example is the searching telephone number from the telephone directory. Okay, so these are what the need of searching techniques. Now we are going to see the linear search and binary search. So first we are going to focus on linear search. Linear search is also called sequential search. Linear search is also called sequential search. So first we are going to see sequential search, or you can say it is also called linear search. Linear search. This is a traditional technique for searching an element in a collection of elements. In this type of searching, all the elements of the list are traversed one by one to find if element is present in the list or not. Okay, what is a sequential search or linear search? A linear search is a very simple searching algorithm, or in this type of searching, the sequential search are made for all the items one by one. What we are going to do? We are going to check every item of list, and if a match is found, then that particular item is written and their location is written. Otherwise, search continue till the end of the data. Let's take an example. Suppose you have an array of size 10, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So you have an array of size 10 having the numbers 10, 20, 60, 90, 1110, 69, 169, 119, 5, 16 and 20. Sorry, 30. Okay, so you have an array of size 10 having the number 10, 20, 60, 90, 110, 169, 119, 5, 16 and 30. Now if you want to find whether 15 is present in this data or array list or not. So if you are using linear search, if you are using the linear search in which we are going to traverse one by one to each items of this array and check whether this 15 is present to every. We are going to compare this 15 with each and every number. If this 15 is matched with any number, so this is what a 15. So here comes the 15. Okay. So if this element in this array, it will return the location and element to the user, or if that number is not present in this list, it will say unsuccessful search. We can perform linear search on sorted or unsorted array also. Sorted or unsorted array also. So this is what a basic concept of linear search. Now what we are going to do, we are going to see the algorithm for linear search and the one example of linear search. So this is what the algorithm for linear search, where we have an array X, the name of array is X, and the value which we want to search. So this linear search algorithm takes two parameters. One, which is an array of name X having the elements. Okay, we already entered that elements like 10, 20, 30, 40, 50. So this is what an array X, the name of that array is what X, and the value, it will take the value which we want to search. So suppose I want to search 40. So these two parameters takes as an input this algorithm. Now what we do, we initialize one variable to 0. One variable to 0. If I is greater than n, if i's value is greater than n is what? The size of this array. So what is the size of this array? 5. So n is equal to 5, and what is I is 0. So if I is greater than 0, if I is equal to 6, means i's value is 6, means it is greater than 0, then directly jump to the step number 7. And what is step number 7? Element not found. And if this condition is not satisfying, then it will jump to the next condition, where we have an array X with index location 0, and we are check whether it is present at index location 0. What we are checking, whether whatever value we are searching, whether that value is present at index location 0. If not, if it is, then jump to the step number 6. If it is, then jump to the step number 6. Step number 6 is what? Element found. If at index 0 40 is not present, then it will increment that I counter by 1. So I will point now index 1. Now this is 0, 1, 2, 3, 4. Okay, and go back to step number 2. Again it will check whether i's value is greater than n. No, it will go to the next step. Check if x of I, what is I value now? 1. So at index 1 40 is there? No. Increment I by 1. Then again 40 is there? No. Increment I by 1. Then again 40 is there? Yes. Then it will jump to the step number 6. So it will display simply the element location find at particular position. So this is what a algorithm for linear search. Now in short, what we are going to do next, we are going to see a small programming or code of linear search. Okay. So here what we are going to do, we have an array of name atoms of size 10. We have one variable, that is element, which we want to search. The element which we want to search, I is a counter variable, and n is the size of array. Okay. So size of, instead of say size of array, number of elements in an array. Since we know that size of array is 10, but maximum element we can hold 10. But out of that, how many numbers we are going to enter? You may be enter 5, 4, 3 or 10 elements. So that I am going to ask how many numbers you want to enter, which is less than 10, which is equal to 10, which must be in between size of 10. So scanf, suppose I enter the 5. So how many elements we are going to insert in array? 5 elements. So this is what your array. The name of that array is atoms. Okay. So 0, 1, 2, 3, 4. So size of array is 5. Okay. Then next what we are going to say, please enter the array element. So this is the code for, this is for logic. So I enter 10, 20, 30, 40 and 50. Now next is what? After entering that element, which element you want to search? Enter the element you want to search. So scanf statement in an element variable, I'm going to collect that element which I want to search. So suppose I want to search element 40. Now after the selecting element from the user side, what I'm going to do? So I'm writing array here again, 0, 1, 2, 3, and this is 4. So 10, 20, 30, 40, and 50. So this is what my array. Okay. Now what I'm going to do? I'm going to apply search logic. In search logic, what we are going to do? Initialize I to 0, index 0. Now your I is pointing to this location. I is less than n, condition satisfied. I's value is 0, is less than 5, condition satisfied. It will jump to the code for loop. In for loop, we have written one if logic. If array of I, array of 0th index. What is we have at array of 0th index? That is 10. 10 is equal to 40. Which element we are searching? No. Condition not satisfied. It will jump to the end of the for loop. I plus plus i's value become 1. Now I is pointing here. Again check I is less than 1 is less than 5, condition satisfied. Jump to the for loop. I array of I. What is the array of I? I's value is 1. At index 1 we have 20. 20 is equal to 40. Condition not satisfied. Jump to the end of the for loop. I plus plus i's value become 2. Now let's check 2 is less than 5, condition satisfied. It will jump to the inside the for loop. Now array is what? 2. At index 2 we have 30. So 30 is equal to 40, condition false. It will jump end of the for loop. I plus plus I become 3. I become 3. Now 3 is less than 5, condition satisfied. It will jump to array of I. What is the array of I? That is 40 is equal to 40, condition satisfied. Or then it will print element found. If suppose if you are looking for the element 70, which is not in an array. So now 70 is equal to 40. No, condition is not satisfied. It will jump to the else part. End of the for loop. I plus plus I become 4. 4 is less than 5. Condition satisfied. Jump. It will jump in the for loop. So at index 5, 50 we have 50. 50 is equal to 40. Condition satisfied. No, it will jump to the end of the for loop. I plus plus I become 5. Now 5 is less than 5. Condition false. If I'm looking for 70, okay, if I'm looking for 70, so 5 is less than 5, condition false. It will jump, it will break the for loop and it will jump. If I is equal to n, what is i's value now? That is 5. 5 is equal to 5, condition satisfied, element not found. Very simple. So this is what? Linear search. This is what? Linear search. So what is the problem with the linear search? So linear search is efficient, not we can say efficient. It is a easiest way or simplest way to find element in the array. Okay, array or in the array. Okay, but problem is what? See, now assume that your array size is 1000. What is that? 1000. And whatever element we are looking at that place, looking in that array, which is not present in that array. So what happened in this situation? This for loop iterate 1000 times, but what we get result is unsuccessful, means element is not found. Or second problem is what? At every time we need to compare with each and every element. So it is okay for the less number of elements. So here we have 5 elements, so it will take less time. But if your array size is more than 10,000, 10,000 or 10,000 or 50,000, so it will take large amount of time. So basically the time complexity of this linear search is n, okay, big O of n n. Okay, so here I'm writing time complexity big O of n. So time complexity of linear search is what? Big O of n. So hence we are going to see the next searching technique, that is binary search, in our upcoming session. Thank you very much for watching.